talking point across the industry. Clearly, there's a major transition happening in the world, the need for decarbonisation and the green transition, a lot of technology in place. What's your view of critical minerals and the impact it's going to have on our industry?
Well, yeah, I think there's no doubt that it's going to have a huge impact, and it's a hot topic at the moment. There are a lot of stats about sort of the demands and increases in demand for critical minerals to help with the energy transition. Just a few, for example, mineral demand for clean energy alone is expected to quadruple by 2050. For example, lithium production is going to have to increase 4x by 2030 to meet that demand. And another interesting one I read recently was that just in the next 27 years, we're going to have to produce twice as much copper than was produced in the last 3,000 years by humans just to meet this demand. So yeah, there's no doubt like you say, this is sort of at this critical turning point, and there's going to be increasing demand for the materials for this energy transition.
Stefan, there's clearly going to be a lot of opportunities and challenges for our industry. How do you see it?
Yeah, definitely. Like you say, there's definitely going to be challenges to meet that demand, but also a lot of opportunities for the mining sector and for tech companies in the mining sector as well. And I believe that ultimately new technology is certainly going to have a key role to play in helping to meet this demand and solve some of the challenges. And that's from all the way from sort of finding new ore bodies and then to better understand those ore bodies during exploration and during development. And for example, being able to mine ore bodies that might have been considered impossible to mine before, maybe too deep or too remote, or to make some other ore bodies viable to mine using new technology. So definitely going to help to alleviate some of the demand through the use of new technology. And I think that's why, for example, IEA had a report on the role of critical minerals in this transition, and they had 6 recommendations, and one of those recommendations was to promote technology innovation at all points of the value chain to help unlock this new supply. So yeah, definitely we see the opportunities for us and others, especially around robotics, autonomy, and AI, and that's all the way from data capture all the way through analyzing that data to deriving insights in the space.
From your perspective, what role is ESG going to play in critical minerals?
Well, it's definitely going to play a critical role. I mean, safety and ESG, or as part of ESG, have always been really important in the mining industry. But I think going forward, as there's more of a spotlight on mining, as people become more aware of the critical role that mining has in this energy transition or providing the minerals for the energy transition, I think ESG compliance will become even more important, and there'll be more scrutiny from the general public and from governments. And again, coming back to this IEA report, one of the other recommendations they have was to have higher ESG standards to make sure that we sustainably and responsibly produce these minerals that are needed. And there's another interesting way of looking at sort of a report by Deloitte on the net zero workforce, and they make some very interesting points. One is they point out that there's currently this kind of paradox. Right now, there's the greatest need for mined products at the moment, but there's also the highest public opposition to mining. So there's a bit of a paradox now, sort of obviously a question of how we overcome that. They also make the point that mining underpins around half the global economy. So it's got the greatest potential of any industry to positively influence the social, environmental, and economic development aspect. So a very important role to play there. And obviously mining does have its own carbon footprint, but they make the point that although it's got this sort of contribution to carbon emissions, the sector's role as a provider of raw materials means that its handprint, or the potential to lower carbon emissions, actually across the broader economy, that actually outweighs the footprint of its carbon footprint. So I think that's an important point to consider and to socialize, that people become aware that mining has this really important role to play. And then in terms of safety, yeah, I mean, obviously, like I said, safety has always been important in mining. Definitely believe that technologies such as robotics and autonomy have a key role to play in safety. Obviously, if you're using autonomous systems to go and do some of the work that traditionally a person would be, in a hazardous, challenging environment, you're removing those people from those environments and improving safety. And the other benefit of autonomy or autonomous data capture is also you can derive more insights about the ore body, what's happening underground. This is for obviously underground environments, and having better understanding of the ground conditions makes it a safer place to be. You can put better safety things in place. So I think robotics has a role to play there in safety, and also new technology like robotics and autonomy definitely have a role to play in reducing the carbon footprint of mining and helping mining companies reach those pretty stringent net zero targets that they've imposed on themselves, or sometimes governments have. And I think this comes sort of in a few different areas. So obviously, as we improve and increase the level of autonomy of mining, it means that you can do mining more remotely. You can have remote operations, fewer people on site, so there's less travel to and from site and less need to support people on site. But then there are a couple of other key things which I think are going to come into play. For example, as we eventually head towards zero entry mining, the whole point of zero entry obviously is to not have people underground. And currently one of the biggest power consumption sort of part of underground mining is ventilation and cooling, to make the space or the environment suitable for people to be underground. So if you remove people from the underground environment, you can reduce the requirement for ventilation and cooling. And again, that's a huge power savings in mining, reducing the carbon footprint. And then there are other areas as well. Just for example, improving the drill and blast cycle, helping to optimize that by collecting better data, helps you to make that drill and blast cycle more efficient and optimal. And again, that can lead to improved efficiencies in the mill. And that's another area of huge power consumption. So there are various ways that I think new technology like robotics, autonomy, and AI can help to reduce the carbon footprint of mining and to improve safety, so helping the ESG side of mining.
Stefan, how's the digitalization of assets and process and things such as digital twins going to impact operations and workflows from your perspective?
I definitely think it's going to have a pretty significant impact. We've already seen a lot of improvements in efficiencies, and when people think about sort of autonomous mining, for example, they typically think about autonomous haul trucks or remotely operated boggers or drills. And obviously doing that level of automation has had an impact in terms of efficiency and safety. But the reality is there are many other tasks that still need to be performed underground or on site that don't require large automated machines. So this is the sort of the jobs that a surveyor or a geotech or a geologist would do, which requires going underground, doing an inspection or taking measurements, and then obviously analyzing that data and helping to make decisions. So eventually, as again we head towards zero entry mining, if you want to have no people underground, you're going to have to automate those jobs as well. So I think there's going to be demand for automating using smaller kind of autonomy or robotic systems, as well as automating the workflows, the digital workflows for those jobs. So our view of the future, or the mine of the future, and this is obviously not just ours, but many others, is that there's going to be that the mine will basically become potentially an autonomous system by itself, where data is continuously collected underground or on site through robotic systems, through IoT sensors, even through the mining vehicles as they're traveling around underground. They will be using sensors like LiDAR to navigate and provide autonomy, but those same sensors can be used to generate updated 3D twin or digital twin of the mine. So yeah, this mine model will be pretty much updated continuously, data fed into a central stored somewhere where it's stored, processed, analyzed, and then used to make decisions. again, autonomously from data capture all the way through to analytics. So I think that digitalization is definitely going to have a key role to play in this mine of the future, and it does mean that certain tasks will change. So, for example, a surveyor won't need to be going underground every day. You might have autonomous systems collecting data that a surveyor can then analyze on the surface or remotely. And there's potential to speed up and make many of these workflows more efficient and safer. One example is convergence monitoring. So if you have to go and detect if there's sort of convergence in a part of the mine, if that data, 3D data, is being collected on a daily or weekly basis, then it's just simply a matter of sort of post-processing that data to determine where there's convergence. And obviously that helps with safety. And there are a whole lot of other examples of where this data that's been collected continuously can be used on a daily basis to improve safety and efficiency.
So, Stefan, the digitization of assets and these workflows, how are they being impacted? And do you have an interesting example of what's being practiced today?
Yeah, certainly. I mean, I think overall there's definitely a positive impact from many of these examples. The one that we obviously been part of for a while is the use of autonomous drones to map and survey stopes after blasting. And obviously the benefits there are, instead of having a surveyor going sort of right up to the bund and using a laser scanner on a boom to scan a stope, you can launch a drone from a safe location. It'll fly autonomously into the stope, map that in full detail, and that allows you to provide better insights. So there's no shadowing, you get more detail in the scan. So a lot of positives from using stopes, from using drones in stopes compared to a CMS type method. And that's been widely used across many underground mines around the world today. And I think another interesting one that we've been working on as a sort of proof of concept now is in the post-blast re-entry process. So typically, in between shifts, that's when the blasting happens, or at the end of the shift, and before the next shift can re-enter, you'd have an inspector going down to check out gas levels, make sure there's been no fall of ground. And only once that's been cleared will the next shift be allowed underground. So the concept we're working on now is to do automated post-blast inspections. So we've adapted our autonomy and mapping to operate on a ground vehicle. This is a robotic dog. So eventually this type of thing will be deployed, staying underground. At the end of the shift, after a blast, basically this vehicle or robotic dog will be sent out on an autonomous mission to go and capture 3D LiDAR data, gas measurements and images, and stream that all back up to the surface so that somebody can have a look and very quickly identify if the gas levels are suitable for re-entry or if there's been a fall of ground, and thereby sort of speeding up the re-entry process. So, even if you're saving 10 minutes in every shift, it ends up making the whole process more efficient for underground operations.
So, Stefan, these technologies are now going through our industry in locations that in some cases we've never seen before. What are some of the examples and the depths and the locations that some of these technologies are going to?
One example is an extremely deep mine in Canada, Kidd Creek. I think it's one of its claims to fame is when you're at the lowest points of the mine, you're actually the closest you can get to the center of the earth. And obviously at that depth, there are a lot of challenges with ground movement. So they have been using OffMap to fly into stopes and other areas to capture data in a safer way. And that mine is more than 3 kilometers deep, I believe.
So given this fast-paced change, what do you see as some of the skill challenges for the industry?
Well, obviously the skills required for mining are changing as new technology is introduced, and because there's a lot of change. So some of the skills needed, for example, are being able to handle change and do change management, advanced systems development and integration, data science, digital literacy, higher level operations and planning, and even things like business information system operations and analysis. And then obviously there's the ability to work with new technology. So as we have robotics, autonomy, AI, machine learning, augmented reality, all these buzzwords come into play in robotics. Obviously the mining industry and people working in the mining industry are going to need to learn to work with and alongside and use these new technologies and tools to be the best at their jobs. And obviously their jobs will be changing as well. So there is definitely opportunities for upskilling across many skill sets in mining. I mean, for example, geotechs might not need to be underground as much anymore, but they will still need to obviously provide their technical insights on the data that might be collected by an autonomous system. So there's more opportunity for them to work remotely at the surface, and the same for a number of other jobs as well. So as data is being captured, that data still needs to be analyzed and have input from the experts. And also, as obviously the mining industry is currently struggling to fill a number of these roles, not so attractive anymore to be out on site. So I think bringing in new technology can help mining jobs be more attractive, can enable them to be performed remotely, so people won't have to be sort of fly in, fly out. Might make it more attractive for the youth of today to work in the space where there's high tech, interesting things to be doing instead of being out on site. And I think also, there's the growing awareness of the importance that mining is going to play in the future for the sort of the energy transition. And I think that's also going to make it more attractive for people to come and work in this industry if they know that they're making a difference to that energy transition.
So, Stefan, is technology going to deliver the much-needed productivity dividend the industry needs to meet these decarbonisation and green transition goals?
I mean, I certainly think so, and I think obviously a lot of people believe the same. There's a lot of evidence already around how new technology has helped drive efficiency in mining, enabling new things. But it's also going to allow, I suppose, a change in the workforce and change of skill sets and a potential for upskilling of existing jobs. For example, a geotech, today might have to go underground quite often to go and capture data and do inspections. In the future, if an autonomous system is capturing that data, the geotech will be able to do that work remotely or on the surface. The same for a surveyor. So yeah, I think there's going to be a transition, and those roles are going to, I guess, need to be able to work with and alongside new tools like robotics, autonomy, use of AI, machine learning, augmented reality. They'll use those tools, I guess, to kind of give them superpowers and allow them to be better and more efficient at their roles. But their core skills will obviously still be very important and required.
So, Stefan, tell me a little bit about your business and the skill challenges you face.
Yeah, it's quite interesting actually, because our business is not a traditional mining business. We're a robotics company. We develop autonomous systems and data analytics, and that is being applied to the mining industry. So our sort of skill composition is mainly sort of we recruit out of STEM for our engineers. Software engineers, roboticists, data analysts, or data scientists. So of around 125 people, I'd say only 5-ish have mining backgrounds and have sort of started off their sort of careers as with envisioned sort of working in the mining industry. Everybody else obviously started off, wanting to get into robotics or computer science, and now they're actually part of the mining industry, and obviously they're an important part in providing new skills and new technology to the mining industry. And I'm sure they recognize that the role they're playing is very useful and important as well to this industry.
So, Stefan, how's the mining industry embracing commercialization and R&D opportunities?
It's been very interesting to see actually, more recently, obviously they've seen the benefit of new technology, and some of the mining companies are actually investing directly in METS companies through their own VC funds. And that's obviously helping to accelerate startups and to encourage them to work in this space relating to mining. And it's actually not just coming from mining companies. We've actually seen quite a lot of new inbound inquiries from venture funds that were traditionally only looking at sort of renewable related technologies, but they now see that mining is a critical step in providing the minerals for this energy transition. So, you know, we're seeing interest from a lot of VC funds that want to invest in mining and metals related technologies, because I see that that's kind of a step to unlocking that value chain and providing the critical minerals.
Stefan, thanks very much for your time on TLS Xtra.
Thank you so much. It's been great to be able to share some of our thoughts and views on this very interesting topic, and I'm really sort of looking forward to seeing how this evolves over the next couple of years, and the role we can play in the space as well.
Thank you.